Another thing that we can do with the formulas that we've been working with is determine how many people we need to survey, how big our sample size needs to be to get a margin of error that we want. So if you want a margin of error of like 3% on either end, how many people do you need to survey, or that kind of thing. So to answer that question, we can use this formula. Okay, the minimum sample size required for estimating a population mean at a given level of confidence with a particular margin of error is given by this formula. N equals your critical value of z times sigma divided by your margin of error squared, the whole thing squared. Remember your critical values of z, they're on page 431. They're also on page 883 in the back of your book, and they're also on your yellow sheet. This formula is on your yellow sheet. Now, where does this formula come from? Well, remember yesterday we had our margin of error formula. Our margin of error formula looked like our critical value of z times sigma over root n. All we have to do is solve this for n. So what I'm going to do to start that process is I'm going to multiply both sides by root n. So get those to cancel. So we have e, oh, that's not the right e, sorry. E times root n equals our critical value of z times sigma. We're trying to solve for n, so now we'll divide both sides by e. Cancel those. So now we've got the square root of n equals all this, and then to cancel all that square root, we'll just square both sides. The square root and the square and cancels. So that's where the formula comes from. So it's just the formula from yesterday, written in a different way. We always want to round up to the next largest whole number. So even if you get like 538.1, still round up to 539 or whatever. So we want to determine the minimum sample size needed if we wish to be 90% confident that the sample mean is within 2 units of the population mean. And an estimate for the population standard deviation is 8.4. Okay, so that formula was n equals, I can't remember it now. Let me look again. Our critical value of z times sigma divided by e, and we're going to square the whole thing. So our critical value for z, that is going to come from this 90% confidence interval. Okay, so we go to our critical values of z on any one of those pages or on your yellow sheet. For a level of confidence of 90%, our z value is 1.645. So we're going to do 1.645 times sigma, that's right here, 8.4, divided by our margin of error. That told us right here we want to be within 2 units of the population mean. So wherever our population mean is, we want to be 2 this way or 2 this way. So our margin of error is going to be 2, and we'll square that. And just grab a calculator. 1.645 times 8.4 divided by 2. Square the whole thing, and we get 47.73, which we need to round up to 48. Okay. So that is the number of people we need to include in this particular study. All right, let's take a look at this one, the last one for the day. We want to know the minimum sample size if we decide instead we want a 99% confidence level. So we decided, on our last one that wasn't good enough. We had a 90% confidence level. Now we want to go to a 99%. So to get to that, we're going to need a larger sample. So we're going to rework that formula. So still n equals our critical value of z times sigma over e. We're going to square the whole thing. So this time we want a 99% confidence interval. So check out your table and see what our critical value of z is. 2 point something, 2.575. Our sigma is the same, 8.4. Our margin of error is the same, still 2, and we're going to square that whole thing. So just grab a calculator, 2.575 times 8.1 divided by 2, and we're going to square that whole thing, and we get 108.8, and remember we need to round that up to the next, because this is number of things to include in our sample size, and is 109. Okay. So again, let me emphasize that we need to be interpreting our results. So make sure as you're working through your homework, absolutely use your TI to the fullest extent. Make sure you're referring back to these formulas. But when it says interpret your results, that's where you're writing a sentence. We're 99% confident that whatever. Okay. We will continue on tomorrow with 8.2.